In this video we're going to be looking at generating terms of a sequence using what's known as a position to term rule. Before we do that, let's just quickly recap using term to term rules. So for example, if I tell you that we've got a sequence where the first term is 7 and the term to term rule is that we add 3, can you list out the first 5 terms of this sequence? Pause the video and have a quick go at that. Hopefully you've got this as your answer. The first term is 7, and then to find the next term we simply add 3, and that would be 10. To find the next one again we add 3 again, which is 13. To find the fourth we add another 3, that gets us to 16, and then to find the fifth term we have to add another 3, and that would get us to 19. So those are the first 5 terms of this sequence, and we have generated these using a given term, in this case the first one, and this term to term rule. So we've just had a quick recap of term to term rules. What we're looking at now is position to term rules. What we have here is an nth term formula, and we can use this to find any term in a sequence, whether it's the first, the second, the third, the fourth, the fifth, the 10th, the 50th, or the 98th, whatever we want. And we do that by choosing n to be the position number of whichever term we want. Let's take a look at this example. The nth term of a sequence is 4n. List the first 5 terms. Now, to find the first term in this sequence, what we want is for n to be 1. So we substitute 1 into this nth term expression. 4 times 1 would be 4. So the first term in this sequence is 4. Now to find the second term, we want n to be 2. We're going to substitute that into here. 4 times 2, that's 8. Now to find the third term in this sequence, we want to substitute n equals 3 into here. 4 times 3 is 12. The fourth term is when n is 4. 4 times 4 is 16. And the fifth term is when n is 5. 4 times 5, that's 20. So we've listed out the first 5 terms. Of course, this sequence does go on, so I'll put a ... there. It goes on forever. If we wanted to find the 100th term, we would just put n as 100. In fact, if you look at this, if n was 100, we would have the 100th term, and that would be 4 times, not n, but 100. 4 times 100, which is 400. So that's how we can list out the first few terms of a sequence, or any particular term of a sequence, using the nth term expression. Here's the second example. Pause the video and have a go at this one for yourself. Here's the answer. The first term would just be 5 times 1, which is 5. The second term is 5 times 2, which is 10. The third term is 5 times 3, which is 15. And the fourth term is 20. And the fifth term is 25. Notice we've just got the 5 times table. That's just like before, when the nth term was 4n, and we ended up with the 4 times table. Here's the third example. Take care with this one. The nth term is now negative 8n. So pause the video and have a go at this. Right, with this one, the first term would be what you get when you substitute n equals 1. So negative 8 times 1, that's negative 8. The second term is when n is 2. Negative 8 times 2 is negative 16. The third term is when n is 3. So negative 8 times 3, that's negative 24. The fourth term is when n is 4. Negative 8 times 4 is negative 32. And the fifth term is when n is 5. Negative 8 times 5 is negative 40. And notice we have got what's effectively the negative 8 times table. Here's the final example for this video. Pause it and have a go for yourself. Here's the answer. When n is 1, we get a half times 1, which is just a half. So the first term of this sequence is a half. The second term of this sequence is what we get when n is 2. So a half times 2, that's 1 whole. The third term of this sequence, that's when n is 3, so we just substitute that in. A half times 3 is 3 over 2. The fourth term is when n is 4, so a half times 4, that gives us 2. The fifth term is when n is 5, so a half times 5, that's 5 halves or 5 over 2. So there we have the first 5 terms. Of course the sequence does go on forever, but we don't need to list any more to answer this question here. Notice again that the nth term of the sequence was a half n, and this sequence is going up in steps of a half. Now, before we finish the video, it's worth looking at why the nth term formula is such a useful thing. For example, let's say I've got a sequence where its nth term is 5n plus 8. I could use this to find out the first few terms, the first, the second, the third, and so on, but I could also use this to find any term I like. For example, if I wanted to find the 1000th term of this sequence, I could do so straight away without finding all the previous terms first. So let's say I wanted to find the 1000th term. Well, to find the 1000th term, what I want to do is make the n 1000. So if n was 1000, I would have 5 times 1000 plus 8. And 5 times 1000 is 5000 plus 8, that gives me 5008. So I know that the 1000th term in this sequence is going to be 5008 without having to list out all of the first 1000 terms. Well, I can do that for any term I like, not just the 1000th. That's why these nth term formulas are so useful.